And I'm pretty sure I tweeted that from the right account. Yes, I did. Good. Always good. All right, here we go. Thanks for joining us once again. I'm Sammy K. Powers, and this is the PHP Roundtable. This is a live podcast of developers discussing topics that PHP nerds care about. And the ultimate goal of this podcast is to learn a little something from each other. If you're listening live, want to be a part of this little shindig, send a tweet to PHP Roundtable, and we'll get your question and or snarky comment addressed live on air if we can. So you're a self-taught PHP programmer. So am I. We might have decades of programming experience, but I'm guessing that you and I would likely fail a tech interview if we didn't study our butts off. And if you've ever wanted to work for a big tech company like Google, Amazon, or Facebook, but have always been too nervous about the tech interview, this episode is for you. Today, we discuss what we need to do as self-taught PHP programmers to be fully prepared for a tech interview. And maybe soon, you'll be showing your friends how to invert a binary tree on a whiteboard. So now that we know what we're talking about, let's meet our panel. And as always, in no particular order, we're kicking it off with Frank de Jonge. Frank, you know, the fly system dude. That's his one-liner intro. Welcome, Frank.
Thank you. Thank you.
We also have Parker Phinney. Parker Phinney is founded Interview Cake, a site for preparing for coding interviews. Welcome, Parker.
Hey, thank you.
We also have Gayle Laakmann McDowell. She's the author of the best-selling book, Cracking the Coding Interview. Welcome, Gayle.
Thank you. Happy to be here.
I have your book. It's awesome. So let's kick this discussion off with kind of looking at what maybe a typical onboarding process might look like at a tech interview. So for somebody who's maybe never tried to apply for tech job before, or maybe has a tech job now but never went through a tech interview, what does a typical process look like from basically start to finish, from that initial recruiting stage to getting an offer? What's that like a really typical kind of way that happens?
So it's, I mean, there's a little bit of variation depending on the company, but I'd say that to give one simple overview of what is fairly average, you'll have your resume submitted somewhere. Maybe you submitted online and got lucky enough to actually get pulled out of that little black hole. Or you came in through a referral. Either way, it goes to a recruiter who then, and often you submit for a particular position. The recruiter matches that up with a position. Maybe the position you applied for, maybe they feel you're a better fit elsewhere. All right, at that point, you will often have a quick recruiter screen to kind of gauge why you're interested. Some basic questions, usually not something super technical because the recruiters don't have that background. And then at that point, you'll go typically into a phone interview with an engineer. This might be called a phone screen, but do not think that means that it's just a basic sanity check. It's not at all. It's a serious interview on par with what you'd see on site. So you'll do one or two of those. There might be a HackerRank assessment at some companies, especially for more junior candidates. And then when you come on site, you'll do typically 4 to 6 interviews. And these will be a mix of behavioral interviews, the kind of standard algorithm questions, and design, and maybe some stuff that's more technical. Some companies will do homework projects as well, or things like that. So there can be some variation. And then at some companies, at that point, your package usually goes either to a hiring committee to make the decision, and the hiring committee may or may not have any of your interviewers on it, or all your interviewers to just meet together to make a decision. And then at that point, you might get an offer semi-immediately after that. Or you, at a bigger company, your package might go to some sort of salary review committee who decides compensation. And then finally, your recruiter gets back in touch with you and hopefully delivers an offer.
Yeah, the only thing I would add to that is that for folks who have never done a technical interview, they may not know sort of like what that looks like at all. So usually it's your interviewer will give you a link to a website that has a shared code editor on it. So you're going to be on the phone, so your interviewer is going to be in your ear over Skype or Google Hangouts or whatever, and you're going to be typing code into your web browser. So there are a couple things that are sort of awkward about that if you're not used to it. One of the main ones is that if you're used to writing code in Vim or in Sublime or something, you're going to be in a different coding environment. And then when you do the on-site interview, you'll also be writing code in real time with your interviewer. In some cases, you'll be at a computer, and in a lot of cases, you'll be at a whiteboard, which has its own sort of bits of awkwardness. So I definitely advise people to practice using one of these web code editors like coderpad.io, and to practice writing code with a pen and paper or a whiteboard if you have one.
Wow, I've definitely not had any of that, whatever you just described as any of my interviewing experiences. I think like there could be some cultural differences. Like I'm based in Amsterdam, so I'm guessing you're all mostly in the States. So like here, because the country is small, basically there's no need to go for phone interviews ever, because if you take public transport, you can be pretty much anywhere in under 2 hours, or like anywhere you want to be is going to be under an hour. So there's very little effort to actually go somewhere. Like my experience until now has mostly been a 1 or 2 step process, where most of the time the technical stuff is not even really touched upon, except for my last experience where I actually did a coding test on the spot that was sort of impromptu. So I did not know it was coming up, and it was my first one. So that was kind of awkward, and but normally the tech interviews that I've had, mostly my jobs are referral based, and then people just ask for the experiences, like how my previous projects went. I've only ever been a freelancer, so that might be different as well then. But mostly it's just experiences, and like having a conversation about how and why things went the way they went, basically. So a lot less formal, I guess, which seems to be a big difference.
Yeah, I really want to ask you actually a few details of a recent interview that you went through. But before we get to that, though, I do have sort of something that I ran to when Googling resources on tech interviews. From the perspective of a PHP developer, it kind of gets a little bit, I guess, discouraging, because you'll see all of these resources out there, and it's like, yeah, just use whatever language you're comfortable with, and they list off a bunch of languages, or they give examples that are in a lot of different languages, but you never ever see anything related to PHP. And it's sort of like, oh, do we just not have a fighting chance, or does that mean that we're forced to use or forced to learn another program really, really well? From the perspective of a PHP developer, is there any recommendation as far as kind of resources that we can start heading towards or learning about?
As far as I know, the fact that PHP isn't included in those like sample lists is just an oversight. I think the bottom line is that companies do mean it when they say you should just interview in your most comfortable language.
Then again, I also think like as practical advice for PHP programmers to interview better would also be really to learn other languages as well. Like in other like non-PHP languages, you're just confronted with the more theoretical stuff more often. That exposure will make you more comfortable like discussing those kind of things, and you can take that knowledge back to PHP. And it's like I've noticed it over the years, like if I've been doing another language for a longer period of time, if I come back, I can just sort of like bring along the knowledge you've acquired. And like I noticed pretty much every time that how I was writing PHP was really different after those periods. And it mostly like the abstract knowledge that you sort of distill from that experience. That's the sort of stuff that I ended up discussing in the interviews, and that really helped.
Very cool. Gayle, I'm sorry I muted you. I think there was something in the background there, so I just feel free to unmute yourself if you're stuck there. Sometimes
I'm back. I kicked my dog out.
Okay, sounds good. My dog just came in. She just got spaded, so I don't know if she'll be awake or not. So, so kind of shifting gears into looking at some more specific things that we should probably focus on, especially if we kind of missed the CS 101 courses. If we didn't actually have go to college for specifically computer science, what are some of the main things that we should be kind of Googling, researching, buying books about, and learning before the tech interview?
So, I mean, so there's a list you can give. So I think Big O notation is one of the most important topics you really got to understand. And it's not that people are going to say, what's the big O of this or this or this? It's that big O, for those who don't understand it, is essentially the language and the syntax we use to discuss how efficient an algorithm is. And the core of these interviews is optimizing the algorithm, right? So you can't do that really without having Big O be so well understood by you that it's now pretty easy for you. So you really got to know that very well. And then after that is your core data structures and algorithms. So arrays, strings, certainly hash tables, binary search and basic sorting algorithms, basic things with graphs. So there's a list that I go through more in my book, and those should be topics that by the time you go into an interview are fairly easy for you. Now, one of the things that people get very wrong about interviews is you'll have people who talk about, oh, you need to know Dijkstra's algorithm and these much more complex algorithms. And there can be bad interviewers out there, certainly, but for the most part, you really don't need to know that stuff. These interviews at their core are about assessing your problem-solving skills, not your knowledge of computer science. So there's these topics you need to know really well, and interviewers try to ask you challenging questions based on that simple knowledge. They're not trying to throw out obscure knowledge.
Yeah, I would agree with that. The analogy I would make is, what you really need to learn is how to think in algorithms, right? How to think algorithmically, and I always encourage people to think of it that way rather than thinking about like learning algorithms, which may mean like learning a specific algorithm like Dijkstra's or Floyd-Warshall or something. Really what you need to do, especially if you're self-taught or don't have an academic computer science background, is learn the language of Big O notation and get comfortable with weighing the trade-offs of different algorithms, different approaches to the same problem. And so if that's something that's new to you, it's something you're going to definitely want to spend some time on. And it's something that's going to be hard at first, and it's going to be very different at first. So if you've ever had the experience of learning your first functional programming language, there's a bit of a similar flavor just in terms of it's one of those things where you're like, oh, I know the basics. I know how to program, but this is kind of a different way of thinking, and it takes a while to kind of wrap your head around it. Similar thing with learning algorithmic thinking. It's something that requires some specific focus, and if you're totally new to it, you're gonna want to resist it, right? You're gonna want to say like, oh, is this really gonna be on the test? Like, do I really have to learn this stuff? But it actually comes together more quickly than you might think. I actually, we have a resource on Interview Cake. Is this, can I plug something here? Is that?
For sure. Absolutely. Y'all can plug all you like.
If you go to interviewcake.com/DSA for data structures and algorithms, we have just a short list of resources there that teach you algorithmic thinking kind of from the ground up.
For me, once again, in the same fashion as before. It's been really a different experience again. The algorithmic thinking has not been a subject during the interviews. However, a large part of the emphasis of the entire interview mostly had to do around more like the soft skill part around it, how somebody basically acts in an organization, how well they have a feel for how they move up and down in hierarchies, when they do that, how fast or how quickly they will escalate, whether they are more comfortable in more hierarchical structures or less so, how much of their effort is spent on purely their craft, their coding, and how much it is like spent on more the political side of getting stuff done. So one of my recommendations would be to sort of reflect on the situations where you had to achieve something in an organization, or in terms of like that whole soft skill spectrum. And often when you think about it, it's quite easy to think about such a situation, but to actually explain it mostly requires you to go over it a couple of times and really get into the sort of nitty-gritty details of why it went the way it did. And like one, it's a good way to do self-reflection on your personal skills, so you'll learn it from it yourself, but also it will give the interviewer a very good insight of what person they're actually hiring. That can, I think, really be a big influence for the outcome.
That's a good point. So as we're focusing on these algorithms and data structures and everything, how likely is it in a traditional tech interview to get these, I guess, like not super algorithm heavy questions about like, oh, how did you, or when did you run into a conflict and resolve it? When did you use data to influence a decision? When did you like have these kind of more like, I guess not real, I don't know if real world's the right word for that, but where do those play a role in the traditional tech interview as well?
Absolutely. I mean, I think, first of all, you're going to see, I think, probably throughout this recording kind of a distinction between what Parker and I are talking about and what our other guest, who I'm very similarly forgot his name. Yes, of course. What he's talking about. And I think part of that comes from that there is a bit of a distinction with how Silicon Valley companies interview versus a lot of other companies. But there's also a lot of overlap. So while algorithm interviews may not be universal across companies, behavioral interviews kind of are. So it'd be very rare to have a candidate go through an entire interview loop with 6 different interviewers and not get asked any question about their background. I mean, that just, I'm sure has happened, but it's not something that happens widespread. You will typically have at least one interview that is focused on your prior experience. Now that is on average, doesn't mean every company does that, but in addition to that, interview, and this is actually something when I do interviewer training, I specifically train interviewers on, don't walk into the interview and say, hi, my name is, so-and-so, and now write me an algorithm to do this. Like it's a horrible experience for candidates. So every interviewer is typically going to start off with at least a few minutes about your background. And it's not necessarily what they're judging you that much on. It's there in part to create a better candidate experience. But when you have somebody and you ask them a question about their background and they just, about a challenging project, and they deliver this really, impressive answer, you're walking into the technical interviews thinking, this person's pretty darn smart. And that's going to bias the interviewer in a way that's favorable to you. So it is definitely something that is important, even in these algorithm interviews.
Very cool. I want to kind of shift the gears back to kind of what we were talking about a little earlier, and talking about specific things that we kind of have to know before popping into these interviews. And there's kind of one that kind of, as a from the PHP perspective, kind of gets me. PHP has just such this like kind of unique niche, I feel like, in this specific place, and that is arrays and hash tables, and distinguishing those two. Since in PHP we have numeric and associative arrays, and we use associative arrays sort of like a hash table. I know they're not like quite the same, but behind the scenes they're implemented as hash tables in the C code that runs PHP. So I guess from a perspective of a PHP programmer who kind of maybe looks at a hash table and like, well, that looks like an associative array. Is there specific things about hash tables that we should know about, like maybe how the hashes are generated, or what the data structures that are behind the hash table? Like, are we using linked lists behind the scenes, or how are we implementing a hash table? What kind of considerations should we consider when thinking about hash tables specifically?
I would say the biggest thing is first to recognize that hash tables are an additional layer of complexity on top of arrays. Arrays are, the way I teach them at least, kind of the most fundamental data structure. The way that memory is laid out in a computer basically is an array. Right. The way that memory works is every slot has an address, and then you can put some bits at each address. So that's mapping a number, which is an address, to some data. So arrays are kind of the most simple data structure. And then what hash tables do is they give you the ability to map something other than a number to some data. And so you have to do a little bit of additional work to augment an array to let you do that. And we explain how that works in the data structures and algorithms guide that I plugged earlier. So I would say that, like, without getting too in the weeds, that's kind of the most fundamental thing, is just understanding that an array is a simpler data structure, because there are going to be some cases where you could use an array or a hash table. And if you don't understand as a candidate that the hash table is the more complicated and, in many cases, not all, slower data structure, you're going to look naive. And it's PHP is not the only language where there is a little bit of semantic confusion, because the hash table sort of data structure is called an array. But it's important to understand that distinction.
And I think one thing to elaborate a little bit on something Parker was kind of getting at is that you want to be mindful of is, in some of these languages that have a whole lot of helper stuff in them, you can get into traps, unintentionally get into traps in the interview where things aren't as fast as they first seemed. And so I'll see this a lot when I interview candidates who are doing Python, where they rely on these helper, all these different libraries in Python, and those are great, but they don't realize that they're calling this thing repeatedly that's actually not that fast. And so whatever language you're working in, is you really want to understand what's happening under the hood, and how these things are working, because some things, most things translate just fine across languages. But these interviews are about efficiency, and if your algorithm is now n squared instead of n log n, that's going to be a big problem.
No, that's really good. So understanding, for example, what algorithm PHP uses for sorts, which happens to be quicksort, I learned. So behind the scenes, those kinds of things, so that you can, when you're kind of analyzing those space-time complexities, you can be like, oh, well, I know this is in log n, so this is how I'm going to sort of assess my code based on what I know about behind the scenes language. Is that kind of what you're saying?
Yeah, exactly. And also so that you can, I would imagine that many PHP interviewers are interviewing with interviewers who, many PHP candidates are interviewing with interviewers who know PHP as well. But sometimes they might be interviewing in PHP with an interviewer who doesn't actually know PHP. And so you're going to want to explain to them that what might operate differently in their language. Or what just made maybe different expectations. So Ruby, for example, has a concept of implicit returns that's fairly foreign to interviewers who don't do Ruby and might actually look like bad practice, except that Ruby is actually the recommended practice. And you as a candidate are going to be advantaged if you can explain to the interviewer how these things work, why they do certain things, so that you don't wind up looking bad when you actually made a good decision.
Very cool. Yeah, I keep coming back to this idea behind PHP, or one of the things that PHP developers, we all like to use, is arrays for everything. It's like when you get a hammer, everything looks like a nail, and I feel like it is the glue that pulls together so many scripts. So I wanted to at least mention a couple of things, part of the SPL library. So these are kind of like standard library stuff in PHP. We have data types in here that I don't know that a lot of PHP developers know about. There is actually one for arrays called SPL fixed array, and it works a lot like you would typically see an array in some other programming language, where you have to set a specific size and then it allocates that much memory, and then you're set to that. So I think if you were to get an interview questions that says like create a sort of like dynamically scaling array, I don't even know what you would call that. Like implement that in PHP. Since PHP kind of does that automatically, I guess you could say, hey, SPL fixed array might help illustrate that I know the concepts behind a scaling array. Would that be a good answer, you think, in a context like that?
That is exactly what you'd want to do. And there's a lot of questions like that where there may be, old questions that have been around for a very long time, and then you translate that to a different language, and it's like, well, actually that language built that in because it's actually a really useful thing to have. And yeah, all you have to do is you say, hey, the language actually, I would mention it to the interviewer, hey, the language actually handles this to this. But if you want to build up from scratch, I can use this other thing. I can use arrays to go build up my hash table from scratch. And that's exactly how you want to handle it.
Yeah. There are even some cases where you really have to fake it. So this SPL fixed array sounds like a good thing for that particular problem for PHP of making a dynamic array. But another common question is reverse a string in place, and many languages have immutable strings. Python is one of them. So you just have to fake it. You make an array of one character strings, and you reverse that in place. Sometimes you kind of have to say like, okay, look, this doesn't really work in this language, but here's the way you can kind of fake it. Another way of putting it is that sometimes what you kind of have to do is like pretend that the data structure is a C style data structure, and write C style code, even if it actually is in a language like Python or PHP.
So can you iterate on that just a little bit, as far as, so say I get a C style data structure. What do you mean by that, as far as just like it has sort of like a similar API that you would see in C? Or
I guess what I mean is take Python, for example. I'm probably just naive to this, but I don't, off the top of my head, know of any fixed size array data structure that is mutable in Python, right? In other words, I don't know of any array that sort of behaves like a C or Java style array in Python. So if I was asked to implement a dynamic array in Python, what I would do is I would use a Python list, and then I would just pretend that it was not actually a dynamic array, and I would do the scaling by hand. So it's a bit of a hack or a bit of a game, but again, I might be wrong, but as far as I know, that's kind of the best you can do.
Couldn't you use a tuple for that? Like I could be totally wrong, but that's
I think tuples are immutable. Am I wrong about that?
No, so I thought you said you were looking for like an immutable data structure which you could emulate a immutable one with.
I'm looking. This is getting a little in the weeds,
but
suppose you want to make a dynamic array. So part of the point is that it is mutable, right? Because what happens in dynamic arrays is that you append things and the size grows. So I think a tuple wouldn't work for that because you can't just.
Oh, yeah, I see.
So I think a simple example of this is, I think this is what Parker mentioned earlier, but reversing a string in place. Lots of languages don't have an ability to modify individual characters of a string. The string is immutable. And so the interviewer asks you to do something that is to reverse a string in place, which is meaning without creating new data structure. That is literally impossible in your language. But to take a step back, what the interviewer is not doing is saying, hey, if I gave you this thing in the real world, how would you go do this? What they're looking for is, can you show me the signals that you would be able to understand how to balance different trade-offs for this kind of problem? And so if you're asked to reverse a string when your language doesn't have mutable strings, well, maybe you can use an array of characters. And so that's I think what Parker was getting at with the writing C-style code. So instead of using a string that can't be modified, use an array of characters, which can kind of sort of be thought of like a string, and reverse that array in place.
That's smart. I like that. So this is cool. So maybe this is using this idea that like we're kind of using the limitations of the language we're using and showing how we can kind of fake data structures from like say another language that has certain restrictions. We can make use of the SPL library for a couple of other things that we're expected to know how to use and implement. One of those is stacks and queues, and there is a SPL stack and there's an SPL queue sitting there right in the standard lib that we could take advantage of. There's also a SPL priority queue, which is a little different, but it does give you some access to these data types that we typically don't use, I think, in like typical web apps that we build. But I'm curious, have you ever expected, I know I've mentioned, like I've read, Gayle, like in your book, you mentioned that you should be feeling comfortable both implementing these and like kind of like know how they work behind the scenes, but that's not necessarily what you're necessarily doing in the interview, right? Like you're kind of expected to kind of know how to implement them and how they work behind the scenes, but they're not going to sit you down and be like, implement priority queue, go.
Unless they do.
Right.
Okay.
So, okay.
So it's a great question. So they won't ask you to, and this is going to sound silly, but they won't ask you to implement a heap or a priority queue or a hash table unless they actually ask you to do that. And what I mean by that is there's a zillion, I mean, I swear, I think most problems involve hash tables in some way. And one of the questions I get a lot from candidates is, well, if I'm using a hash table or I'm using sorting, do I have to implement sort? No, generally speaking, not. The point of that interview question is not to go do this much more complex algorithm that happens to involve a hash table and then also implement hash table and then implement this a zillion things. Typically, if you're using something then that's built into the language, or even something that would be built into other language. If it's just something you're using and it's not really the point of the question, no, you're not going to implement it. But there are other interviewers, personally, I don't like this as a question, but there are lots of other interviewers who will actually say, implement a hash table, implement quicksort, implement whatever it is. And so, yes, you might have to implement it, but that's when you are explicitly asked to do so. If you're not, what I encourage people to do when they tackle the coding portion is just assume everything you want is built in. Off the bat, just be like, oh, I'm going to use this helper. Look, I have this magical helper function that, I don't know, compares to see if two arrays have the same sum. Probably not built in almost any language, whatever. Use it as a helper function for now. Implement the more important stuff, and then start pulling back the layers in, okay, now I'm going to implement this helper function. And at some point, you're probably never going to, you're going to get down to implementing something like comparing if two arrays have the same sum, if that's a method you need. You're probably not going to say, okay, now I'm going to go implement this binary tree, because that's really not the point, and you just don't have the time to do that.
Yeah, I would say just to echo that point, I think a lot of people before they have their first coding interview worry that the picture in their head is that they're going to be given is like a test in school, like an exam or something, right? They're going to be given something, and then the interviewer is just going to be silent for an hour while you kind of flop around and you're not sure what's expected of you, and you feel judged and watched. That's very rare. That can happen. Usually that's just because your interviewer is bad. But that's very rare. For the most part, a coding interview feels a lot more like a practice co-working session. Of course, your interviewer does expect you to do the majority of the work, but she'll be very clear about what she wants you to do. So if you start, implementing a hash table when that's not really what she wants the problem to be about, for the most part, she'll say, okay, well, let's actually just use, let's pretend we have a hash table already, right? So your interviewer will, for the most part, kind of steer you towards whatever they want you to be focusing on in the problem.
That's great. So I want to focus on a few other things that we should definitely know about. One is linked lists. I don't want to get into too many details. I hear there's some I've seen a couple of places online where people are really anti-linked lists and they're like, oh, it's a horrible data type. You only need to know it for tech interviews and things like that. But if you do need it, there is a SPL doubly linked list in PHP sitting waiting you free to use if you need a linked list implementation. For us PHP people. But there's also sorting and searching, knowing about the, like you mentioned, sorting and searching algorithms. And I think that of all the things that we kind of need to know, dynamic programming and memoization are kind of what we PHP developers are probably most familiar with, but it looks like a big scary word. I think we do this all the time as we do a lot of object-oriented programming, and a lot of our scripts take advantage of this sort of dynamic programming / memoization technique. At least for me, that's what I kind of resonated the most with, is like, oh yeah, I kind of already do this already. So I don't want to get into too many details about that, because I want to talk about the one big scary data type that I feel like everybody kind of cringes at, and that is trees, binary trees, graphs, all those kinds of things. Why are those scary? Why do I think binary trees and just cringe a little bit? Like, is it just unobtainium? Like, how do I start with these things?
So, I mean, I think one of the reasons why it's scary to people is you don't really use them a whole lot in the real world. I mean, tons of things are built with trees, under the hood, but I don't know. I mean, most people tell me, like, I've never worked with binary search trees in my life. Like, yeah, and you know what? Neither has anybody else, unless your job is like me, Parker, and it's doing interview stuff. You don't really work with binary trees. And so it's this stuff that it's not fundamentally any harder than frankly, hash tables under the hood are frankly more complicated than binary trees. You just don't use them a whole lot. And it's just a matter of practice. Practice plus a little bit of recursive thinking that a lot of people, again, haven't practiced that much.
Yeah.
So practice makes perfect.
Exactly.
Yeah, and I would say sort of the same thing I said earlier, which is binary trees are massively like this. For some folks, linked lists are also like this. There's this like resistance at first if you're really not comfortable with them, of like, oh my God, is this really going to be on the test? Do I really have to know this? This is such a useless data structure or whatever. But it does, it comes together faster than you would think. And when it comes together, it kind of comes together all at once. And then once you have it, well, I can say this confidently about linked lists. Maybe I definitely forget and have to relearn things about trees pretty regularly. But a way that you can really kind of get into getting comfortable with these data structures is to not worry so much about like learning the data structure like it's going to be something on a test, but to seeing it as a lens for developing algorithmic thinking in general, right? And I think that's the context in which linked lists come up in a lot of coding interview questions, is that the important thing is that you have the ability to weigh the trade-offs between using an array or using a linked list to implement a queue or a stack, right? It's not so much that like those data structures are super important as that they're like a lens for seeing if you understand trade-offs.
I think there's also one other reason why people get very scared of trees and graphs, and that's that there is a lot of complex knowledge there. Whereas linked lists, I don't often hear about like, oh, this researcher developed this fancy algorithm with linked lists. Like, there just isn't that much there. I mean, I'm sure there is, but you don't hear about it. Whereas trees, you got AVL trees and red-black trees, and then you have tries and suffix trees and prefix trees, and then you have to. There is a lot of research around trees and graphs, and that just scares people. And the reason why I'm saying it's not that scary is not because it doesn't scare people, but it scares people for reasons that it shouldn't. Interviewers generally are not and should not be asking people to implement red-black trees or AVL trees. That scary knowledge is generally not expected. What you have to know is really not that complex. It can still be a little scary because you're not used to it, you haven't practiced it. But what you have to actually know is not that complex.
I love that because it does kind of make it less unobtainium. And I've actually been studying and trying to learn binary trees on my own. And I've literally just been drawing circles and drawing some lines and kind of like thinking, okay, if I'm on this node of the tree, how do I get to this node? Or how do I like know what my siblings are? How do I know what my parent and my children are and all that things? And I literally was bringing it with me to like, we have really cool neighbors. We go hang out with them all the time. And I brought my little paper over and I'm like talking with them. I'm like, here, this is what I'm trying to do. I'm trying to develop an algorithm that would determine the parent of this node. And we just kind of sat there and talked it out. They're not programmers, but they're just people who can look at a problem and be like, oh, I would just do this and this. And so together we kind of tried to come up with an algorithm. And now I feel a lot more comfortable in binary tree talk because I started realizing that there's a huge correlation with binary trees and straight binary and bit manipulation. And a lot of the same sort of, like when we talk about shifting bits and those numbers correlating with how many nodes are in a binary tree and all that kind of stuff, it really started like making it super clear, like, oh, you know what? I can just do some relatively simple math to figure out if I know any given index, like how to manipulate whatever it is I'm trying to manipulate. And so I want to throw this out there officially, a milestone today that happened. To kind of segue into kind of like, we need to wrap it up. So I'm kind of trying to make a nice little segue here into some of the criticisms of doing tech interviews. And there was a famous, kind of a pretty famous tweet at this point, I guess, by Max Howell, who's the creator of Homebrew, who tweeted, Google, 90% of our engineers use software you wrote, Homebrew, but you can't invert a binary tree on a whiteboard, so bleep off. And so this is one of those kind of famous sort of things that happen in a tech interview when you have this person who went to interview who has some legit experience would have been probably a really great candidate, but because they failed this whiteboard, this arbitrary process or whatever, they weren't offered a job. And so I guess this inverting a binary tree on a whiteboard sort of been in the back of my head as like the problem to solve. Yeah. And today I figured it out. I did it. I just kind of used my knowledge of what I learned of binary trees, thanks to your all's help with what you all have offered. I've used both the interview cake and the cracking the coding interview book. But I am curious about the this whole process of or this whole idea behind tech interviews being this like arbitrary thing that you don't do anything related to the actual position that you're going for. What are your thoughts on that?
So I love that question. There's so much there to discuss, and I won't go into everything. But so first of all, yeah, Max Howell, it sucked for him. I'll be honest. I totally understand where he's coming from. It's hurtful, frankly, when you have something, you think you deserve it, you expected to get it, and you didn't. And that is a blow to anybody's ego. And I think that's fundamentally what happened there. And there's a great answer from him on Quora, where he, a year or two after he sent this tweet, went and addressed them that. And he backed off a little bit from it and gave a little bit more information. I think that inverting a binary tree was not the actual question. It was, I don't even think he intended that to mean this is literally what I was asked. I think he intended it as like a hypothetical question. And actually when he'd given more details at some point right after that tweet about what no one seems to understand what inverting a binary tree actually means. But I think there's a broader point there, which is that, hey, he's a great engineer. He's built this cool stuff. Why doesn't that merit a job at Google? Why are they asking this stuff, which is super computer science-y, that gets guys like him ruled out of the process? And what he actually explained on Core was actually really interesting, because what he kind of said was, he still maintains he deserved that job, more or less. But what he kind of said was, look, I'm not a great computer scientist, but what I am is I'm great at figuring out products. And that's, my comment to Max was more or less, that is wonderful that you are great at figuring out what product people want. That is an incredibly, incredibly valuable skill. It's just not what Google needs in a software engineer. That's what Google needs in a product manager. It's not what they need in a software engineer. What they need in a software engineer is people who are smart and can write code. That is fundamentally what they're looking for. And that version of smarts is tested through computer science and being able to solve tricky computer science problems by using your brain. And he's not a computer scientist, and he admits that. And so he got rejected, and that's probably the right decision, unfortunately. Doesn't mean he's not a great engineer in a different environment, but he's not a great engineer at a company who needs computer scientists. The interview process is designed to hire people who are smart, and to hire them in a way that very rarely gets not smart people hired. And they understand that actually there's also a whole lot of smart people who just get rejected from the process because they get nervous, because they don't know the right stuff or whatever, and they accept that trade-off.
Yeah, I agree with all that for sure. I sometimes describe it as like, the difference between being the type of engineer who can sling some code, and the type of engineer who can come up with, right? So, I guess to back up, the type of engineer who can come up with something that works versus the type of engineer who can come up with everything that works and carefully weigh which working solution is actually going to be best in terms of efficiency. And then as you get more senior, sometimes you're also weighing stuff like how long it'll take to implement and stuff like that. And so that's really what the Google style data structures and algorithms and big O notation coding interview is trying to test, right? Is that, that question of, can you come up with something that not only works, but is actually, among all of the things that works, the best thing for a given context. And so that's, at a big company like Google, that's going to really be their focus. Because they're building things that really have to scale, right? So they have to be really efficient. At a smaller startup, that may be less of a focus. So that they may be more interested in people who have more cross-disciplinary skills, maybe people who are great programmers, but also have some good product sense. Maybe they may weigh kind of velocity, right? How quickly you can ship a feature a little bit more, and the efficiency of that underlying code a little bit less, right? Because they don't have a lot of users yet, and that's not the most important thing for them. On the other hand, they may, even as a small startup, they may see themselves as like, well, eventually we're going to be Google, right? So they're trying to build a Google caliber or Google type team. So it's really a mix in terms of how companies think about this. So a lot of companies are going to do the Google style data structures and algorithms thing, but there's also a big set of companies that vaguely, it seems to me, might be growing, that are going to do something that's a little bit less data structures and algorithms focused, a little bit more, how would you build this feature? Maybe more specific questions about like the tool chain, so like PHP specifically, or any PHP framework that you're using, and potentially also like product sense kind of stuff.
I also like, not to re-spark the entire discussion all over again, but like wonder how much of the interview process is influenced by how well it is to interview, or how well it is to determine a particular skill in an interview. Like if you've got those exact things, like explaining an algorithm or walking through something really technical, that's relatively easy to assess. Something is mostly right or mostly wrong. While if you're looking at the more technical strategic side, like the one up from algorithms, maybe in like system thinking or stuff like that, that's already like far more things come into play. So it's less easy to sort of create this funnel where you know that you've got a big pool that wants to work at your company and you want to narrow it down to get the best people. Like, it's easier to do that when it's easy to quantify the outcome, basically.
Oh yeah, I mean, I think what you said is absolutely true. I mean, there's a lot of reasons that we do not have time to go into talk about why companies do this. But one reason why companies do this is, look, you know what? The big companies do it. It's worked well enough to build companies like Google and Facebook. It's something we can train interviewers on, although most companies don't have training. But people can learn how to do this. They can. It's much easier to scale than a lot of other things. It hires people who at least are pretty smart. Maybe they don't know a whole lot, but at least they can learn that. And we can scale this process, and we can have people interview across teams if we're short on interviewers. It's a much simpler interview process to roll out than a lot of other alternatives.
I feel like we could have a whole other podcast dedicated to just this topic, because I have so many sub questions I want to ask too, but we really do need to wrap it up. We're getting kind of close to that time. So I do want to kind of end on this final thought. There's so many things I want to get into on the show notes, but we'll have to save it for later. Do either of you, or do any of you have any final thoughts or any final tips that a self-taught PHP programmer could, like, encouragement for us before we go for that big position at that big tech company?
Yeah. So, I'll tell a quick story. So one of my good friends was about 5 years ago, was prepping for, he was like previously working at, to call them startups would probably be generous. These aren't the Silicon Valley high growth startups. This were like small tech companies that really weren't doing all that well. And anyway, he got an offer, got a possibility of interviewing for Facebook. And I was like, all right, well, I'll help you out a bit. And he was like, awesome, fantastic. So started prepping this guy, and I'm like, okay, so obviously hash tables. And he gives me this blank stare. He's like, what? And I'm like, oh boy, like, this is like the most core thing you have to understand. If he doesn't know hash tables, he did not understand any of the other words I threw out there. About a month later, he got an offer from Facebook. And this is surprising to a lot of people because he didn't have any of the knowledge he needed to have. But the reality is that he's a smart person. No, he didn't know the computer science stuff, but he's smart and he can solve problems. And all that stuff that people think is so much to learn, it's really not that hard to learn that stuff. What's hard is developing that kind of algorithmic thinking. And he had that because he's fundamentally smart. And he went to Facebook, is doing very, very well there. I'm still waiting for my 5% commission on his salary. Joking. Should have set that up in the beginning. But and I think that's actually, I mean, it's a little bit atypical only because of how little he knew. But what I've seen over and over again is that people who are self-taught are not fundamentally at a big disadvantage. They're not less smart. They're not worse programmers. They just don't know some stuff that they can easily learn. The biggest thing that hurts the people who are self-taught is that panic. They've learned that stuff. They actually know the stuff they need to know. But then I ask them something about binary trees, and they go into this, oh my gosh, I've never used this before in my life. And what I tell them, like I mentioned earlier, is nor has anybody else. It's fine. You have all the stuff you need to do. All you need to do is think about the problem. The biggest thing that hurts people who are self-taught is just an insecurity, a lack of confidence. It's not that they are fundamentally going to have a much harder time getting an offer once they've learned that basic knowledge.
I would add to that probably a lot of the self-taught people, as I am myself as well, we're not really used to doing any deliberate learning. I would say mostly we're getting confronted with these things, and then we learn on the fly. We figure it out. Like sometimes we take a little pain, we implement it the wrong way, and we suffer through it, and then we learn from that. So to reiterate your point, those things are learnable, and you need to be sort of comfortable with the mindset of deliberate learning as well. And that's a whole different mindset. So yeah,
absolutely. Yeah. I would say it's learnable, and it's you may have this idea that it takes 4 years because that's how long an undergraduate computer science education takes. But as per Gayle's story, I'm guessing, Gayle, in that story, what happened in that month was that your friend learned some of this stuff, right?
Exactly.
To prepare for the interview, right? So the point there is that it's going to feel foreign and new at first. It'll feel like learning how to program again. Honestly, that's why I made the analogy of learning your first functional programming language, right? It's just kind of it's sort of a different way of thinking. But it comes together much faster than you think. I've seen people go from 0 to quite proficient at talking about data structures and algorithms in just a long weekend. So you just have to give it some particular focus. And so again, not to be too pluggy, but interviewcake.com/DSA. We have a guide that's just a couple hours of reading that's meant to really kind of prime the pump on this stuff and let you hit the ground running.
Nice. This is awesome. Thank you so much for the encouraging words, and sort of what Gayle was talking about. If you do experience this imposter syndrome, there is an entire episode of the PHP Roundtable dedicated to that, episode 67. Go back and take a listen. Imposter syndrome and the Dunning-Kruger effect. We go into detail about that. So as a self-taught person, if you're feeling that imposter syndrome really setting in during a tech interview, maybe the words that Gayle, Frank, and Parker have just given you will help encourage you, and hopefully some of the words in the episode 67 will help as well. It's really close to wrap up time. I'm sorry, I don't want to go over too much because I want to make sure I'm respectful of your all's time. So I just want to wrap it up really quickly. The PHP Roundtable elephant, the plush toy that is slated to be on sale in 2019, might be a sale before. Oh my goodness, talk much, Sammy K. It might go on sale sooner than that. So lots of things have been going through that. I'm excited to maybe tell you about later, but sooner than later, hopefully. So just a heads up about that. If you want to contribute to the PHP Roundtable show notes, you can find it on github.com/PHP Roundtable. There is a repo there called show-notes. All the show notes are in Markdown. Contributed the show notes in Markdown. I'll give you a live shout out here on air. So thanks for everyone who has been contributing the show notes. And without further ado, let's wrap this thing up with some shameless promos. Let's start off with Frank. Do you have anything that you would like to shamelessly promote?
Well, that's not really. It's like if you use Fly System, maybe sponsor my Patreon account. that would be awesome.
All right, awesome. What about you, Gayle? You have anything you want to promote?
Yeah, say check out Crack the Coding Interview. It's actually Amazon's best-selling interview book over all categories. I go through a bunch of just talking about why this process exists, what they're looking for, how, obviously how to prepare, how to walk, a bunch of different strategies for how to walk through questions. And then I just go through about exactly 189 questions. And then if there's any employers on the other side, I also do the other side a lot and do interviewer training and helping companies structure their hiring process.
Excellent. What about you, Parker? You have anything you want to promote?
Yeah, interviewcake.com. We have a bunch of resources to prepare for coding interviews. We've got practice questions. We've got that intro guide to data structures and algorithms at interviewcake.com/DSA, data structures and algorithms. And we also have a free newsletter you can join to get a practice question in your inbox every week. So you can find all that stuff at interviewcake.com.
Wonderful. Well, I hope you'll join us in our future episodes. The next one will probably be doc blocks, annotations, and the like. There's also a couple of others slated for later on down the road. GDPR for PHP devs, all things Drupal, and a live accessibility audit of the phproundtable.com website. So it'll be embarrassing all the things that are not accessible on the website, but I'm going to do it live in front of everybody so that you can make your own websites more accessible. If you have something you'd like to share about a specific topic that PHP nerds care about, check out phproundtable.com. There's a form there you can fill out and be like, I want to hear about this, or I want to join the panel. I'd love to hear from you. My Twitter handle is Sammy K, or you can ping the PHP Roundtable on Twitter. I'd like to thank Frank, Gayle, and Parker for joining us in this discussion, and we'll see you folks in the next episode. Peace.
All right. Thank you so much.
Bye.
Thank you.